Press the bell icon on the YouTube app and never miss another update.
Hi students, we are discussing on the straight line graph and taken some examples in the previous video. Let us take one or two how will a straight line grade from this linear equation and enter into the another curve. Let us take for example 1 y is equal to 2x. So if you are studied in high school, the pattern I am showing to make it more convenient, x and y, if you go on the giving the data, when you put x is 0, y is 0. When you put x is 1, it become 2. If you put 2, 2 2s become 4. Or if you put 3, it becomes 6, 3 2s. So that means if I draw the curve for this, taking x and y along that and 0 is the origin, let us some magnitude 1, 2, 3, 4, 5. So it may be 1, 2, 3, 4, 5, let me 6. So now take the first coordinate, 0, 0 is the origin. The second 1 and 2. For this is a linear equation, we get 1 and 2. Suppose if I take, this will be the 1 comma 2. And similarly 2 comma 4. So if I take this is a 2 comma 4 point. And again 3 comma 6. So this will be 6. And coming to the 3. So if I join this, we will get a straight line curve. So drawing the curve, just I am showing y equal to 2x gives you a straight line curve. That locus of the points gives you a straight line curve with a definite slope. So this equation gives us linear variation of in physics y with respect to x. The equation itself suggests you that value. So just one example given. We can trace another one curve. Before that, just take it down. So come to the example 2. If it is x minus 3. Is again a linear curve. So like that, imagine the points x and y. 0 is 0. If you put 1, x is 1, 1 minus 3 become minus 2. If I take x equal to 2, 2 minus 3 is minus 1. If I place x equal to 3, y becomes 0. So it is, x equal to 0 is minus 3. Let us come to the curve. Y values are negative, therefore x and y 1, 2, 3. So it is minus 1, minus 2, minus 3, 0. So first point 0 and minus 3. When x is 0, it is minus 3 is a 1. 0 comma minus 3. When is 1, minus 2. So we get point here. Minus 1, minus 2. 2 minus 1, it is 1. 2 minus 1, we come to here. 2 comma minus 1. 3 is 0. So if we joined, we will get a straight line. The curve will be of different form. So in the two cases, finally I am coming to, before conclusion, with various discussions we had on the straight line graph. So equation of the form ax plus by plus c0, or the standard equation we taken y is equal to mx plus c, which called as a linear equation, or take extended to an example x by a plus y by b is equal to 1. So equation is appear to be in that form is linear equation, and I told x and y in this case a and b are the corresponding intercept. X intercept is a and y intercept is b. So these equations geometrically gives you the straight line graph. I take another one example and conclude with that. So note it down first. So the example third, find the sum of squares. Find the sum of squares of intercepts of coordinate axis of the equation two x plus 3y is equal to 6. So this is the question asked. Find the sum, addition of squares of intercept of coordinate axis. That means we taken a and b constant in the previous relation shown. Square of them, what the answer is. On seeing this equation, when I am coming to the solution here, you are given 2x plus 3y equal to 6. Divide by 6, 2 by 6 plus 3y by 6 is equal to 1. So further correction if you made simplified is y by 2 is equal to 1. Now we have standard equation x by a plus y by b equal to 1. Compare these two. On comparison, we are able to get the values of a and b. You know a is nothing but x intercept, which is equal to 3 is a x intercept. B is a y intercept which is equal to 2. Now we got a and b values that they are asked intercept of the coordinates we got. What we have to do? Square and then sum. That means the second part of this question is having, in the first part we got the x and y intercept of the equation given. Now they are asking about a square plus b square is equal to 3 square plus 2 square. 3 square is 9 plus 4, which answer is 13. The question is on this. Find the first intercept of the coordinates, square them and then get the sum. The answer is this, a square plus b square equal to 13. So we studied in detail about the straight line, which oftenly comes in various chapters in physics. The similar curves I told you, the parabola and hyperbola, even some extent ellipse and circle. Let with this we come to the another curve that is equal to parabola. Yes, this second graph we have to discuss on parabola. It is a shape of curve obtaining by using some equation. If the equation is formed ax square plus b x plus c equal to y, with the x and y are variables, a, b, c are constant, and a should not be 0. This term should exist. Otherwise, if it is becomes 0, then it is a linear equation, we get a straight line. Ax square plus bx plus c equal to y, with a is not equal to 0. When we put the different values for x, knowing the values of a, b, c, a may be 1, c may be 3, 2 may be 5, some constant values a, b, c may have, give different values of x as you did in case of straight line curves. We get the value of y. Taking y as the ordinate and x as abscissa, we can draw the curve. So we can get the different values of x and y. We can point the positions on the graph, and if you join them, trace the curve, which we call it as a locus, we get the shape what we from this equation. What the shape that is available on the curve graph is nothing but called as a parabola. Which shape we get on the graph? Geometrical shape that we get is a parabola. For this, let us take a simplest case. That y is equal to ax square with a as a positive constant. B and C are 0. I taken B equal to C equal to 0. The equation is of the form y is equal to ax square. So if you put the different values there itself, if I take now after this y equal to ax square, I can write x square if I made again a is equal to positive 1. Now we have to give different values for x and find the value of y. Let it be 1, 2, 3, 4 like that. Here minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4. Minus 1, minus 2, minus 4 units. This is the coordinate. If you put x equal to 0, y is 0. X 0, y is 0. You got the point 0, 0 here. One point I got. Put x equal to 1, y is 1, x square is 1. Therefore, 1 and 1, if you this is the coordinate 1, 1 point. Similarly, if you put x equal to minus 1 square is again plus 1, y is plus 1, x is minus 1. So equivalently minus 1 and plus 1, and here we get x is minus 1 but y is 1. If you put x equal to 2 square is 4, 2 equivalent to 4. If I move like here and this x, so I get a point here, it is nothing but 2, 4. 2, 4. So you put like similarly minus 2. Minus 2 is 4, plus 4. Again y is 4 but x is minus 2. Equivalently, I can think the point here as minus 2, 4. So I have some points. If I join them, locus of these points, we will get the shape. That shape is nothing but called as a parabola in geometry. So if I join these points, the curve is appear to be passing through this origin, meet at the origin, shape will be of the form. Now concave, curve is upward, concave upward. For the graph, y is equal to ax square or y is equal to x square we got. The curve is found to be of a C form, shape C almost, but it is concave towards upward. Now think the equation, another y is equal to minus ax square. If a is 1, again plus 1. Y is equal to minus x square graph if I plot. Similar case you take. In the same graph I show you. So y 0, 0, the first point is again obtained 0, origin. If you put plus 1, it gives minus 1. Why is because plus 1 square is 1 but minus 1. So we get 1 and minus 1. Even though it is plus, here it is x is plus but y is minus. If you take minus 1, again y will be minus because minus 1 square is 1 but minus remains as it is. Therefore, we get a point on the opposite side which is having minus 1 and minus 1. If we place 2, 2 square is 4 but minus 2 as a minus 4. So, we get point here as 2 comma minus 4. Take minus 2, minus 2, minus 2 square is 4. So, that again we get minus 2, 4. So, almost the point here that minus 2 comma minus 4. So now you see the point, this is also there, 0, 0. If you are joined them, the locus will get, the shape what we get is a parabola, but it is concave downward. So now I hope you are adjusting how the shape is coming up. It is concave upward if I take y equal to x square or x square. It appears to be downward, concave downward for y equal to minus x square. Let us see what happens in the another curve. Here also itself I try because the place is available. I show other two curves reversing this. Let us take the case third. X is equal to ay square or x equal to y square, taking a is equal to plus 1, a positive integer. Similar graph I can take x and y 0, 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Now take the values. If you put 0, x is also 0. 1 point is available at the origin, intersection point of the two axes. Let take 1, then it become 1. Both are 1 and 1. So we have a point here 1 comma 1. You take y equal to 2, x become 4. For 2 we have 4, so point is here 2. Y is 2, it is 4, 4 comma 2. X is 4, y is 2. So let us take y is minus 1, but x is 1. So y is minus 1, x is 1, 1 comma minus 1. If I take y is 2, minus 2, but x is 4 plus, so we will get two equivalent point here, 2, the point here 4, that 4 comma minus 2. Now see the beauty of the curve how changes. If you change the variation, x is as made y square. Here y equal to x square, there x equal to y square. The curve is similar, shape is not changed, but it is turned towards right. We are saying the point is turned towards right. So concave towards right. Curve is appeared to be bent towards right. It is turned by 90 degree towards east. Similarly, if I take curve, if I take x is equal to minus y square, taking a is equal to 1, but minus y square. So again x is 0, y is 0, y is 1, x is minus 1, 1 minus 1, x is 1, y is minus 1. I taken y is plus 1, but x is coming minus 1. If you take y is minus 1, again x is also minus 1. So we get a point here, minus 1 comma minus 1. If y is 2, x is 4, but minus 2 minus 4, point coming here, x is minus 4, y is 2. Similarly, minus 2, if you take, again it is minus 4, minus 2 minus 4, you will have the point here, minus 4 comma minus 2 coordinates. So curve we are seeing bent towards the left. So we will get the curve which is concave towards left. See the shape how comes. I taken the standard equation. I am not getting otherwise. If the equation of the form, in the simple form y equal to ax square where b and c is 0, the vertex is at the origin, vertex of the parabola is at the origin, may be upward, may be downward bent, concave towards upward or downward, or it is to the right or left. In this case appears to be. So if you extend it, what happens? The vertex may shift, but parabola shape is not changing even if you take the ax square bx plus c equal to y. I go to one or two examples of that type before going to the next part. First, I hope we are taken an equation ax square plus bx plus c equal to y with a not 0. Geometrically, if you draw the graph, that graph shape that we are getting is called as a parabola. And we discussed the 4 different cases. With the y equal to x square, that equation shows to be vertex is at the origin in all the 4 cases. Curve may be concave towards upward or downward or rightward or the leftward. So please note it down. We go to the next part then. Let us take the example 3. Y is equal to 3x minus x square. An example. So how the graph is? Now we are seeing it is of the form y is equal to ax minus bx square. C is 0. A and B is alive. So before plotting to get the graph nature, as you have experience taking the values of x and y, Let us take some values. If I take 0, this also x is 0, you get 0. So if I gave 1, it become 3 minus 1 is 2. If I given 2, for this 2, 3 2s is 6, 6 minus 4 is a 2. If I given 3, 3's are 9, 3 square is 9, answer is 0. So I have some 4 points. Let us try to get the graph for this. X and Y, maximally in the first quadrant all are positive values we are seeing. So let I take 1, 2, 3, 4. 1, 2, 3 and 4. 1 is coordinate 0, 0. 1 coordinate is fixed. Again 1 and 2. 1, but it is 2 approximately here. 2 and 2. This is also 2 and this also 2. Then when come to 3, it is 0. That means x is 3, y is 0. See, this is symmetry. This is 1 meter away, it is 1 meter behind, the same height. So this suggests the curve will be almost bending like this. So this is extending, no doubt. But I have not taken such data. Now you got the parabola curve with the vertex at some point. So if I change this simply, how the beautiness of the graph you can think. If I take y is equal to x square minus 3x, same data you take values, how the curve can think. X and y, put 0, 1, 2 and 3. X is 0, y is 0. If I put x is 1, 1 minus 3 is minus 2. Minus 2. If I put this 2, 4 minus 6 is minus 2. Again if you put 3, 9 minus 9 is 0. I taken simple examples so that it should not consume the time. Time should be saved and our concept should become clear. So that is, take the now x and y. 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. 0, 0 is here 1 point. 1 minus 2. 1 minus 2 is here. 1 comma minus 2. 2 comma minus 2. X is 2, y is minus 2. Again x is 0. X is 0, y is 3. Now reversal of the curve you see as we have seen in the previous cases. So now the curve will be like this. The vertex may be somewhere at this point. So I think you have followed how this parallelogram appears with equation ax square plus bx plus c equal to y. Simple y is equal to x square we taken, y equal to 3x minus x square, or even with a constant it may be shifting in the shape. Shape is not changing, the positions of the vertex may go to different position points, but shape is remain as a parabola. If you take equation, remember either y equal to x minus bx square or y equal to x square or y equal to x square plus bx plus c, the standard curve that we get is nothing but a parabola. This curve we will get for that equation. Let us see that before note it down. So let us take an example here, a node under parabola. If I plot the graph of y square versus x become a straight line. Y versus x is a straight line in linear equation is true. Instead of y versus x in the same parabola equation, instead of taking x versus y, so far we discussed with y, instead of y, if I selected y square as the variable, ordinate variable, x related to y square, if I plot the graph, it will be a straight line. So without confusion, in entrance cases, it is must be very careful when you see the graph, whether it is linear or variable with a physical quantity. I am not saying mathematics, but in physics, see immediately whether it is y or quantity is a square term or linear term. So for this, let us take equation y is equal to ax square, where a is half. If I take y is equal to half x square. To convince you, I am taking this. So this may be written as x square is equal to or 2y square. X square, no, we want y square, right? I make the correction. We need in y square, therefore x is equal to ay square equation. So this a, if I take half, x is equal to half y square, because y square versus x, that can also be done. Graph will be coming in the other quadrant. To make it convenient in the first quadrant, I taken again the same, I changes made. Or this can be written as y square is equal to 2x. Let us come to the points x and y. X and y square. X and y square 0, 1, 2, 3. Let us see. If I put 0, y is also 0. If I place 1, y square become 2. If I place 2, 2 is 4. If I take 3, that become 3 2s is 6. If I take 4, 4 2s is 8. The variation is x y square. For every value of x, we got y square value, not y value, y square value, remember. Now see how the graph come to be. Appearance of the graph, how it is. So take this 0, 0. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8 maybe along the y square axis. 0, 0 is a 1 point marked. 1 and 2, it is 1, but this is 2. 1, 2, 2, 4. Sorry, 2, 4. Here it is. 2, 4. And similar 3, 6. If I move the 6 point here. And similarly 4, 8. So let us see 3. This is 1. Okay. Now you are seeing it is a straight line. The higher point not proportionate to the scale, you leave it. So we got a straight line. Suppose at the same time you see the curve that it is appearing to be a straight line curve. Now if I made y, what are the values of y? For the same value of x, I am fusing the two graphs to convince you. 0 is 0, no doubt. 2, square root of that is root 2. And 4 is 2, root 6 and root 8. 0 is 0, same point. But root 2 is around 1.4. It is 1.4. 2, when I got 1 is x. You have to get root 2 is 1.4 something. So it is y is 1.4 something here. 1 get 2 italva, sorry. Not mentioned here. So it is 1.4. ಇದ್ರದ್ದು 2 ಕರೆಕ್ಟ್ ಆಗಿದೆ. So that so it is around 1.4. This line you leave it. And 2 is 2. It is also 2. It is also 2. Somewhere we get this value. 3 root 6. Root 6 is around 2.4 like that. 2.4 is less than 3. Less than 3 for 2. 3 for 3. For 3 it is less than 3. So we got point here. And for 4 root 8 is around 2.8. Very near to 3 but less than 3 for 4. So we curve here. What we will get is the curve is moving like this. It is a parabola. This is the curve for x is equal to ay square, where x is proportional to y square. If we plot y square versus x, y square x versus x become a straight line. Please remember. Suppose if you taken y versus x for the same graph, if for the same equation, if you plot, it is a parabola. If in a parabola equation, y versus x, if you plot, parabola shape comes. But in case if you plot y square versus x, the same graph will be converted into a straight line. Please remember this as an important note. If the plot the graph of y square versus x, or x versus y square, x versus y square, or y versus x square, y versus x square, or x versus y square, it is a straight line. This may be square term, or this may be square term with this x, y, or it is y square, it is x, or if it is x square, it is y. In that, it will give a straight line graph. So with this, let's come to the other curves. So before going to the other one, so the second curve or graph we observed is ax square plus bx plus c equal to y gives you a parabola, or it may be y is equal to ax square, or y is equal to ax square plus bx, or ax square plus bx plus c. It represents a parabola. Curve, how it is changes, you come to know. In the graph when we are plotting, y versus x, no doubt for x square plus bx plus c is a parabola curve. But if you draw the curve for that, y square versus x or x square versus y, the curve changes to be a straight line. You remember this much as for physics concerned in geometry from the mathematics. Let us go to the another one important curve. That is nothing but ellipse. So you are recalling, you may be studied in high school, but in also in physics in high school you come across with the Kepler's law. You studied that planets are moving round the sun, shape of orbit, the first law of Kepler suggests is an elliptical path. The shape appears to be geometrically is, if you are having best knowledge of the circle, when you stretch the circle along the horizontal or along the vertical, the shape that arises is called as a ellipse. The standard equation that we directly comes to here is x square by a square plus y square by b square is equal to 1. Is a standard equation which represents an ellipse, where a and b that we coming to say it is what the a and b values after drawing the curve. So elliptical shape I am shown, the stretching along the horizontal. So this is the intersection and it has two foci, F2 and it may be F1. And this height is called as this half the vertical height is a semi-minor axis. And this is A, which changes along x, y. This is called semi-major axis. Semi-major axis. These are the foci. So along with this we define a term, I am using only connected equations, that eccentricity of the ellipse given by root of a square minus b square by a square when a is higher. So this eccentricity related to this we can write this minus AE, the distance, and this is plus AE, gives you the curve. This knowledge you have to remember. If the equation comes in the form of x square by a square plus y square by b square is 1, it is an ellipse where A is a semi-major axis and B is a semi-minor axis. And E term what we introduce here is called eccentricity of the ellipse, which fixes the position from the intersection of the axis to the foci position. That is AE, magnitude if you take AE, this is also AE, where A is the eccentricity, value is given by a square minus b square by a square. This is the case when you stretch horizontally and getting the elliptical shape with this. If you interchange this, you will get the another curve. I can plot here y and x. Now the shape will be coming off the form. Vertical stretching. So now B is higher than A. This is A. Again F1 and F2. So this nothing but plus BE, eccentric value. This become minus BE because this is the origin. MC is vertically stretched, the circle, and got this. And as for eccentricity equation here is B is higher, semi-major is then B square minus A square by B square. So this gives you the eccentric value, position of the focus. And further here one important term you have to remember in terms of physics required is, so this curve is tracing under this equation, the locus that we got, named it as a ellipse. But one important condition, any point you can take generally point P, having coordinates as x and y, very significant relation with foci. The distance of F1 to P and F2 to P That means if I take in this F1P plus F2P is always remains a constant. This is the important condition you have to know. So let the point P, when it comes to this position x2, y2, particle may come tracing down to this. So here it appears to be F1P is less but F2P is higher. But again this condition is true, that constant value is not changing. That makes the shape to appear under this equation. So even at the point P is here with the xy coordinate. So if you join them, you will get the F1P plus F2P remains a constant. That is the beauty of this ellipse. And this relation which I am saying, we are using in Kepler's law to get some sense in physics. So elliptical shape, equation for the ellipse, x square by a square plus y square by b square is 1, where a and b are constant called semi-minor axis and semi-major axes, and eccentricity term which fix the position of the two foci. Circle has one focus center, but here that has two foci. The distance of the foci from the intersection of the axis is got with the help of eccentricity. It towards left is minus a or towards right is plus a. And one condition I told, the tracing of points anywhere you can move. Under this equation, if you take x and y coordinates, substituting for x, getting y value, knowing a and b, taking x value and getting the value of y, if substitute, you will get the shape. As we have discussed in parabola and straight line, you will get the ellipse and the position will be like that F1P plus F2P remains always a constant. This you remember for ellipse. And one term, surface area of this ellipse is again required to understand the Kepler's laws in physics as you enter to that surface area of ellipse. That equal to pi AB. You know what is the A and B values here? B and A. Knowing semi-major and semi-minor axis values, you can calculate the area of the ellipse, which help you to know the speed of the object which is moving in that path, elliptical path. Fine students, today we have discussed about starting with straight line, taking some examples and enter to the parabola equation, and also discussed how the shape curve changes in different directions, the equation how supports that shape is. And again lastly, one important term I told, variation of the same equation y square versus x. If you plot, parabolic curve is converted into a straight line graph. And again I brought this third curve, third nature, that is ellipse. Under this equation, if you plot the curve, you will get the shape what we are getting here under this equation, taking definite values of a and b, putting x and varying the y, we get the values. The shape of this form is called as an ellipse. And related to the ellipse, you have to remember eccentric formula, and also this equation standard, and this condition, foci to position of the point. The point wherever on this ellipse you can note down, it always remains a constant. F1P plus F2P is always a constant, remains to be a constant. That gives you this shape, and knowing the surface area of the ellipse what it is. Remaining we'll discuss in the next class. Thank you, one and all.